Okay, so we are back with Quadratic Template, but we are going to be looking at a couple more problems. So same thing as yesterday, where we are going to fill out 2, and then you're going to do 2 for your homework. So if you look at today's, automatically it looks a little bit different because we have a negative in front, which is basically just going to make it go downwards. So let's see what we can fill out before we start coming up with other equations. So first of all, just looking at that, we know that the parabola will open down. And then thinking about if a parabola is opening down like this, the vertex has to be a maximum. And then it asked if there's a vertical stretch or compression. So you look at the a value, or the number that is in front of the parentheses or in front of the x. And in this case, it's just 1. So technically, there is no stretch or compression. The domain for all parabolas is all real numbers. We don't know the vertex yet. The axis of symmetry we don't know until we find the vertex. The y-intercept, we need standard form. Technically, we could find it, but we know that it's a little easier in standard form. And then the x-intercepts, we do know. Remember, you set both of those parentheses equal to 0. So it'd be -2, 0, and 4, 0. Okay, so from here, let's go ahead and put this in standard form first, because that will probably be the easiest. So to put it in standard form, you're just going to multiply out. So we have -x plus 2 times x minus 4. So what we're going to do first is actually multiply the x plus 2 times x minus 4, and then we'll distribute the negative. So this would become x squared minus 4x plus 2x minus 8. And then from there, I'm going to combine like terms. So we get x squared minus 2x minus 8. And then I'm going to distribute that negative. So we get -x squared, positive 2x, and a positive 8. And actually, from the beginning, I could have known like all of these are going to have a -1 as the a value. So I can fill that in. And now we'll go ahead and write standard form, which is -x squared plus 2x minus 8. Okay, so next is vertex form. So to put it in vertex form, you take your standard form and you complete the square. So we are going to complete the square. And then just as a reminder, when you complete the square, a has to equal 1. So then we're going to write out the equation. So we get -x squared plus 2x plus 8. So we have to divide by -1 to make a equal to 1. So when we do that, we get x squared minus 2x minus 8. And I'm going to go ahead and make this equal to 0. So then we want to move that c value to the other side. So I'm going to put plus blank on both sides because we're going to come up with a new c value. Then we make our square to complete. Yesterday I did the b divided by 2 method. Today I'm doing the square method. So we get x squared, first term, first box. Then you take your b value, divide it in half. And then we fill out the edges. And then you multiply -1 times -1, which is 1, which will complete the square. So then we get x minus 1 squared equals 9. And then after that, you want to subtract the 9. So x minus 1 squared minus 9. And the last step is we have to multiply back by that negative. So you get y equals -x minus 1 squared and then plus 9. So we're going to go ahead and write that up here. So -x minus 1 squared plus 9. So now let's fill in the remaining parts. So we now know that the vertex is 1, 9, because remember, to find the vertex, you're looking at vertex form. And then we also know that the axis of symmetry is x equals 1. And then the y-intercept, remember, is the c value in standard form. So it's 0, -8. And then we'll keep waiting on the range to figure out what that will be. Okay, so we're going to cancel out that column in this one, or row, I should say. So we have the vertex is 1, 9, and then I'm going to pick two numbers smaller than 1, like 0 and -1, and two numbers larger, like 2 and 3. And then I'm going to plug them in. So you could put it in any form, but personally, I think it might be easier to put it in the factored form. So we're going to plug in, remember they're symmetrical, so I'm going to pick 0, and I know that that will have the same answer as if I were to plug in 2. So if I plug in 0, I get negative, and then 0 plus 2, and 0 minus 4. So that would be negative 2 times negative 4, which would be positive 8. So then we know this is positive 8. And then we're going to plug in 3, or -1. So we get negative 3 plus 2 times 3 minus 4. So this will be negative 5 times -1, which will be positive 5, which means this is positive 5. So from there, we can't really fit this on the graph, so I'm going to scale it and go by 2s. So just so that way we could fit that 9, and then I'm going to do the same thing on the x-axis. So it'll just look a little different. Okay, so we have our vertex is 1, 9, which is up here. Then we have 0, 8, and we also have 2, 8. And then we have 3, which is in between 2 and 4, and 5. And then we also have -1, 5. Okay, so from there, we're also going to plot our x-intercepts because, yes, we do have 5 points, but we want to figure out where they cross the x-axis. So -2, 0, and 4, 0. And then we are going to go ahead and graph that. So there we go. Okay, so looking at the next example, actually I forgot to do a range. So because it's going down, the range is going to be y is less than or equal to 9. All right, next one's probably our hardest one yet because we got some fractions, but we'll kind of kill them and make it easier. So we're given standard form, so we want to see, well, what do we already know? So the parabola will open down because it's a -1/2. So I'm actually going to go ahead and put -1/2 in all of these slots because we already know that the a values will stay the same. The vertex, because it's opening downwards, so again, I'm going to draw a little sketch. The vertex is up here, which will be a maximum. There is a vertical stretch or compression. It will actually be a compression because it's 1/2. Domain is a freebie. It's always all real numbers. And then we don't know the vertex yet. The axis of symmetry, we do not know yet. The y-intercept, we can easily see it's 0, 5 halves, or we can say 0, 2.5. Okay, so I'm trying to think, probably the easiest step is to put it into factored or intercept form because we just are going to factor it. So I'm going to go ahead and write factored form. And in order to put it in factored form, you have to factor. But looking at it, we have -1/2 x squared minus 2x plus 5 halves. I don't really like those numbers, so what I'm going to do is multiply everything by 2. Okay, so if we do that, and actually even better, I'm going to multiply by -2. If we do that, it's going to make our lives a lot easier. So I want to get rid of that negative a value, and I want to make it a nice number. So let's multiply everything by -2. So then you get x squared, you get a positive 4x, and then you get a -5. Okay, that looks much nicer. Then we factor. So going back to factoring, remember you take your first term and put it in the first box. We already have our c value. It's not completing the square, remember. We take our last term, put it in that box. I'm going to make my little diamond. I know that -5x squared is at the top. My middle term is at the bottom. I need two numbers that multiply to -5 but add to 4. So that would be 5x and negative x, and then you fill those in the boxes, and then you come up with your edges. So we get x, x, 5, and negative 1. And so our factors are x plus 5 and x minus 1. And then we have to remember that we had that negative 1/2 technically in front. So when I write this out, I have my negative 1/2, it's already there. And then my factors are x minus 1 and x plus 5. All right, well, if I know my factors, then I know my intercepts. So my intercepts would then be positive 1, 0 and negative 5, 0. All right, so last step is to put this in vertex form. So to put it in vertex form, just like we did last time, whenever you're putting in vertex form, you complete the square. So also just like the last problem, a has to be 1. So right now, the a value is negative 1/2, so a needs to be positive 1. So what we can do is, again, we're going to multiply by negative 2, because that will make it 1. So I take my negative 1/2 x squared minus 2x plus 5/2, and I'm going to multiply this whole thing by negative 2. So then I get positive x squared, positive 4x, and negative 5 equals 0. Okay, so what I'm going to do is now get rid of that negative 5. I'm going to move it to the other side, which would make it a positive 5, and then I'm going to come up with a new c value. So to get that c value, we have to complete the square. So I put my first term in the first box. I can't do my last term because I don't know it yet. I take my middle term and divide by 2, and then I come up with the edges. So we get x, x, 2, 2, and then you multiply 2 times 2, which is 4, and this would go here and here. So then you write your factors, which are x plus 2 squared equals 9, and then we know we have to subtract that 9 over. But because we multiplied by negative 2, we now have to divide by negative 2, or we can just multiply by negative 1/2, because that's the same thing. So if we were to do that, we would get negative 1/2 x plus 2 squared, and negative 1/2 times negative 9 is positive 9/2, or 4.5. So we will write that. So we get x plus 2 squared plus 9/2. And then now we know the vertex. It would be negative 2, 9/2, or you can say negative 2, 4.5. The axis of symmetry is x equals negative 2. And then we're going to start graphing this. So we have our vertex is negative 2, 4.5. And then I want two numbers bigger. I'm getting rid of that row. So I would have negative 1 and 0, and then negative 3 and negative 4. Okay, so I can plug these numbers into any equation, but to me, the factored form looks like it'll be the easiest. So I'm going to go ahead and plug in negative 1. So I get negative 1/2 times negative 1 minus 1 times negative 1 plus 5. So this would be negative 1/2 times negative 2 times 4. So let's think about this. Negative 2 times 4 is negative 8. Multiplied by negative 1/2 would be positive 4. So then this means it will be 4. Now 0 is always a nice number to plug in. So we have 0 minus 1 and 0 plus 5. So this would be negative 1 and positive 5. So negative 1 times 5 is negative 5. And then we multiply that by a negative 1/2, and we would get positive 2.5. So this one, we don't need to adjust our scale. It'll fit just nicely. So we have negative 2, positive 4.5, which will be in between 4 and 5. We have negative 1, 4, and negative 3, 4. Then we have negative 4, 2.5, and 0, 2.5. And then that's enough points, but we want to make sure that we have the right x-intercepts when we cross it, and luckily we know that. So the x-intercepts are 1, 0, and negative 5, 0. So then we would draw the parabola, and just looking at comparing the two, you can see that the one on the left is more narrow compared to the one on the right, which makes sense because it's compressed. And then the range is going to be y is less than or equal to 9/2. And that is it.